Okay, awesome. So our next speaker is Eduardo, and he's going to talk about animations. So I want to tell a little story before, and this was during the speakers' dinner, and it seems that Eduardo is really funny. It makes faces, like really. He's not expecting to do these faces, but the Chopin brothers were literally crying, looking at him. So maybe if you find any of these faces happening during the talk, you just laugh, okay? Let's do that. Okay, give a warm round of applause for Eduardo.
Thank you, everyone. I'm so happy to see you are even more today than yesterday. It's very exciting. Really, thank you for coming. Today, I want to talk about state animations. My name is Eduardo. You can find me around as Posva. I'm on the core team. I'm also the author of Vue.js 2, VueMotion, Vue2Easing, and some other libraries. I also do workshops around Europe, and etc. And I figured out, so I have many demos around the slides, okay? So I figured out, why not let you go through the demos at the same time I do it in the slides? So if you have a phone, a computer, I really encourage you to scan the QR code or use the bit.ly URL, because you can play around yourself with the demos, and some of them are funny. And of course, if you don't have, don't worry, I would just be showing the same things. It's just for you. I will share afterwards the code as well in a GitHub repository. And I want to give a shout out to Nuxt, because I made the website with Nuxt, and it actually helped me to make VueMotion and Vue2Easing SSR compatible, which is really nice. Also, the website is a PWA with no features. It has no icon, no colors, but I could add more things very easily. So thank you to Nuxt and Sebastian and Alex for helping me to do that. Okay, as many of you, I think animations are hard. They are really, really hard in my opinion. I'm not a designer, so I have a look. I like to design things, but I have opinions, I rather say. And animations are hard because you can animate so many different things, and you can animate them all at the same time, or just pick some of them. And you have so many properties you can pick. You have so many moments where you can do the animation. So it's really hard to combine all these things and get the animations right. For example, you don't want to animate too many things on the same screen, right? Because it's going to look awful. You're going to lose the user attention, because the point of using animation is making something move on the screen so the user reacts and see what happens. And I'm just tricking you here because this is actually an activity monitor, so they are not meant to be displayed in the same page. They are just meant to be shown one at a time. But it doesn't stop there, right? You still have to animate things correctly. Imagine having this pop-up that takes forever to appear. It will completely piss you off. At least, personally, I hate when pop-ups take forever to appear. I will, come on, I would rather edit the CSS with a Chrome extension to make them appear faster, right? So it's hard because you have to control the animations. They have to be fast. You don't have to take too much time. So for example, around 300 milliseconds. And as a developer, when you take your time to create these animations, you want the user to realize there is something happening, right? So it's hard to say, okay, I have to make the animation more subtle, so the user may not realize it, but it's actually having a real impact. And you know, it's always better to not have an animation at all, rather than have a slow animation, much better. Also, when do you animate? So we can animate when the user does something because we want to give the user some kind of feedback. This is actually something that started a long time ago with computers. So the hourglass icon changing is a way of giving feedback to the user. It doesn't matter if it's really an animation, but just the fact that the cursor changes to a different icon is already enough. And nowadays, we use that to create, for example, some loading spinners or things moving around to see if things are happening. So it's really useful to make the user feel like things are going smoothly. And actually, sometimes it can even make the user feel things are going faster than they are. Also, you want to seek the user attention. So there is a notification, a message comes from the user. You display this nice slide down animation with a box, and you say with a toast, for example, you say, hey, you got your message. And also you have, when you just want to make things funnier, and I think the Vue.js Amsterdam conference is a very good example of that, because things are a bit slow, but that's the point of it. You want to have some kind of animation going on as if it was a movie, or, I mean, a movie, as if it was a movie. And actually, because it's in a theater, it makes a lot of sense. In Vue, you already have very good tools for that. You have transitions and transition group. So one for single elements, transition, and the second one for transition group, for multiple elements, sorry. And the way you manipulate them is using, so it's making sure that the element or the component gets out or in the view. So basically, you find yourself using vif, the key attribute, and vshow. And for list, you also have v4. So it's a bit limited in some sense, although the key attribute is actually quite useful, because I don't know if you know about this trick, but if, for example, Vue is going to try to reuse the components and elements as much as possible out of the box, which is great, actually, because it prevents some problems on performance. But sometimes you still want the transition to happen, right? So for example, if you have a router view, and so you have a page with a div, and you have another page, it's also a div, and you want to wrap the view into a transition. When you go from one to the other, Vue is going to reuse a component. So it's not going to trigger the transition because there is no component going out and going in. But if you use the key attribute and you use with vbind, you give it a dynamic value that changes based on something, you will force Vue to actually get the component out and get a new component get a fresh component in, which will trigger the transition you are in, which is very useful. And the cool, but also the limiting part of this is that you are using CSS or JavaScript. Now, the JavaScript API is very powerful. You can actually do anything you want. But the CSS API has some limitation, and that's the one you're going to use the most often. It's limited to elements appearing, elements disappearing, or elements reordering. But also, and more importantly, it's limited to CSS properties. And this is a big limitation. Because you can only modify, and usually you modify the transform, like translates, rotations, because you know they are accelerated by the GPU, and also the opacity, because it's also accelerated by the GPU. But what if I want to animate other things? What if I want to animate my SVG? What if I want to animate the values on my SVG without using CSS? So that's why we have state animations. Now, what are state animations? Well, actually, the concept is very simple. It's how to go from one state to another, because it's just so generic that you can do so many things. But we have many. What is that? Okay, the text is missing. We do that. It doesn't matter. So the first type of animation or state animations you can have are Boolean states. So changing one Boolean value to another and maybe applying a class. Usually it's a Boolean toggling. The other one is easing functions. So this is an easing example, and it's a mathematical function that describes how a value should go from a starting point to an ending point in a specific duration. And then you have a physics-based approach with springs that allows you to update the values on the fly, which is actually, it feels very natural, but it's used in very specific scenarios. Yeah, I actually messed up the text, so that's the text I want to show. You have Boolean togglings, easings, which is the first one at the top, and you have physics at the bottom. Okay, so the first one, you have probably used this one, is Boolean state class switching. Now, whenever you see that little finger there with the text, it means that you can check the demo, and it will be displaying the same thing you see on the right. Okay? So this is the most basic kind of state transition. You have a Boolean value that will change or switch a class and will, for example, trigger a transition. So you can do it, for example, with an on-off switch. And the thing is, if you do it very quickly, so if I keep clicking, you can see that the transition doesn't finish because easing transitions have a time. So they have to finish before being able to go on to the next one. So as a safe choice, I will tell you, for example, not to use these kind of transitions if you don't have a linear easing, which most of the case is what you have. I mean, what you don't have a linear easing most of the time because it doesn't feel that natural. But most of the time, don't apply transitions on things that are very visible to the human eye, like rotation, translation, scaling, because if you interrupt in the middle, the user will realize very quickly that the animation is not natural because the speed is not constant, and therefore there will be a very noticeable speed change on it. If you use it on opacity, colors, and other things that are more subtle, the human eye is not able to realize how it changes. So it's actually OK. And the way you do that usually is with computer properties. So you probably have used this code already. I think it's one of the greatest things you can do with Vue is create a computer property with all the classes you can use. You map that to the state, and boom, you just bind the class, and you have something working already. But this is the easy part. Let's go into something more complicated, easings. So when you have an easing, what you're saying is, I want to go from this value, 10, to 100, bouncing out in 1 second. And what you have is an initial value of 10, a target value of 100, and you have an easing, the bouncing out. And the duration is 1 second. On the right, what you have is the graph. So it's dynamically generated as we compute the value, as we do the transition. And it's using Vue tweezing, which I will talk about later. And if I want to change and see how other things are working, for example, Elastic, I give it a try, I can see how it behaves differently. You see how the value changes. Now, to quickly explain the graph, what you see on X is the time, because the letter is very small. And on the Y-axis, you have the value. And the red line you see is just the target value, in this scenario, 100. OK, and so you can try, the funny thing here is trying other things to give out. You can change the way it works to make it look different. I think, which one was funny? 1, 2. To me, the funniest one is always bouncing, because you see the graph, and it doesn't make any sense, right? You're here, and you see how it's a ball bouncing, but reversed, because the value is going to 100 instead of going the other way around. Now, what about springs? Springs are much more simpler in the way you describe them. You just say, go to that value quickly and with no oscillation, which basically is the friction. Now, the way we represent that is 100 is the target value, quickly is a high stiffness, and no oscillation is a low damping. Now, what are these parameters? I don't want to go deep into the math, because that way is approachable to anybody, and I don't know so far as I may need. But as you can see, we have this stiffness parameter and a damping parameter. And if, for example, I click on no wobble, which I think is the one selected, you will see the graph generated. There you go. Sorry, I was in the right side. You will see the graph generated dynamically. So what you see is the last rendered and a finished at. And the reason I have two values is because at the end there is very little oscillation, because we're using a spring. So the value change is very little. It's almost not noticeable by the user. So you probably don't want to take that into account for the duration of the as a duration for the animation. But this can get very funny, because the things you see here, so the wobbly effect, for example, you look how it looks a lot like the elastic one, right? But if we change the damping, you can see here, to other values, we can see how it starts to oscillate more, okay? So if we go down to 1, for example, you're going to see how it oscillates a lot. And the interesting part here is we can do crazy things. If we go to 0, it will oscillate forever. There is no friction, so it goes back and forth all the time. And this is actually very powerful if you think about it. We can do very crazy things. Also, I can change the value as well. It's going to change how it looks like. It's going to change how much back it goes. And you can play around with the values if you ever want to create a motion with a spring to see what kind of motion is better fit for your animation you want to build. So if we compare the features, easing is highly customizable because we're using mathematical functions that we can customize. You have a lot of existing easing, so it's very easy to pick one existing function from the internet and just use it the way it is. And you can have custom duration. It's easy to chain as well because you have that very specific duration you are sure it will take, which is not the case for the motions because they may take different time to finish. You also have playback control, which is nice because you can use something else than time to control the animation. Now, we're going to see that is very, very funny. The spring, on the other hand, has other features. You only have two parameters, So it's much simpler in that way, but also more difficult to customize. It always feels natural, and this is the main point of Springs. They all will feel natural, no matter what. You change the value, they will adapt on the fly, and this is very important for Springs. So you handle interruptions and changes very naturally. So how do we do easings, for example? Well, you have to use something like Twin.js or any other twinning library, like GreenSock or anything, but the amount of code you have to write, as you can see, is kind of a lot, right? I have to say, well, I have my container, I go to that value, it takes 1 second, so 1,000 milliseconds, and whenever I update, I will probably use that value and put it back in my data if I put that into a Vue component. But if I even want to also re-trigger the transition every time I change the target value, I also have to watch for changes. So it adds a lot of boilerplate. And this is the part that it's made me go crazy, because I think we are losing one of the best features of Vue, which is declarativity. So let's get back that declarativity using something like vue tweezing, which is a component that is going to give you back that declarativity. So this is another example, easing with a mouse, to showcase the easing combined with the playback control. If I move the mouse on top of the demo here, and you can do it with a touch move as well, just make sure not to reload the page, because it's very easy to reload the page by touching the screen. But if I go up, you can see the ball is going to initial position. And I'm using just a bounce out easing. So when I go down, it bounces, and then it keeps going back again. So this is a good example of not using time, but using something else, like the scrolling and the mouse position or anything you can imagine. And the good thing about this is not, well, we're doing an easing, okay, we know how to do easing, we have a lot of libraries, a lot of examples. What is really cool about this is how we write it. The way we write it is very, very simple. It's declarative. So we use a tweezing component, and we're saying we're going to 1, because I just use a percentage. That's easier. I'm using a custom twin engine that takes into account the mouse position instead of time. And I'm saying the time, so the current value for the time is a mouse Y percentage. So basically the percentage of the mouse relative to the screen size. So at the top is 0, and at the bottom is 1. Making me be able to control the actual animation. And then the tweezing company, what it's doing is handling all the changes, watching for you, and is nicely serving you that twin value into a slot scope. So at the end, you just have to write that very nice syntax, and you get back that declarativity you always liked with Vue, which I think is pretty amazing, right? Let's dive into another demo. The Polygon example, you may have seen this example from the documentations. Is written by Chris, and it uses Twin.js as well. Now, the code is using the same code I showed you before, creating a twin, and then you watch for different values to re-trigger the twin. So here what I did is pretty much have the same, but I added vue tweezing on it, so the code is much simpler. And I can change things like the easing equation on the fly. So for example, if I want to go elastic, I can do that. So it looks like the way. If I want to add a lot of size, I can do that as well. So you have this kind of animation that looks like a molecule, right? And it's pretty cool. And you can also make it with a very big radius if you want to, although it's not very visible that way. So you can have very crazy animations with a very declarative approach, which is really nice. You have other things that are very funny as well. The bounce, always funny, the bounce, because it goes back and forth. It's really quite funny. You can try them on the phone as well. If you don't forget, you just click on the Polygon example. I hope the internet didn't let you down, the Wi-Fi, I mean, because I know it's not serving very well. But the good thing is, this is how we write the tweezing. So we are saying we're going to go to stats, which is just an array of points that declare the different position in that polygon you saw. We are using the duration that we provide that can be changed dynamically, and when it changes, it will re-trigger a new twinning. And we're using this easing equation that we selected on that dropdown. And then we have the same thing. We use a slot scope to get the new array that is twin, so it changes on the fly. And we put all the points, we call a function to transform that point that goes from 0 to 1 to the actual position on the circle. So the tweezing component is actually quite simple when you think about it. It's just watching a target value, and it creates a tween whenever the value changes. And then it gives you that value nicely in a scoped slot. So the thing is, we get back this nice syntax I really love about Vue is just changing a value the way you always did. And then the tweezing will trigger on the fly, which is really exciting. We can also provide multiple tween engines. So if you want to use something different than tween.js, WinSock, or Tweezer, you can actually use a helper. Now, I don't provide a helper for every single tween engine, of course, that is out there. But I have one for Tweezer and tween.js, and I'm expecting to add more, probably WinSock as well, because it's widely used. The way a helper looks like is a bit like that. Now, I don't want to go through everything, but the concept is you have a helper that returns a function, and that function is going to be invoked every time we create a tweening. So every time the value changes, you're going to call that function, and it's going to return the new tweening, and probably also start it. And the good news is tweezing is very small. It's actually less than 1 kilobyte. Of course, the helpers may be bigger if you need them, but the tweezing component itself is very, very small. Let's talk about springs now, which in this time we're going to use view motion. So I'm taking this example. It's an SVG chart that Sarah created. It was using the tween, I think it was GreenSock probably, TweenLite, I think. So it was using tweening. So when you change the data set, you will see the values go from one value to the other. But something that I wanted to change is if I change the data set very quickly, I don't want to see how it stops and then it goes up to another value, completely changing the velocity. So if I click on random, for example, to provide different values, if I just do it very slowly, I will see the value changing normally. But if I do it very quickly, I can see it feels very natural. I can even let the enter bar, the enter key press, the enter key pressed, and it doesn't feel that something is starting over. It's very natural. You can change them on the fly, any moment. It will interrupt itself. It doesn't matter. It will go naturally because we're using physics, so it works very well. And it's declarative as well. It's declarative as well because, have a click outside. We have a motion tag that we can provide some values. And these values is just the arrays of the different values you have on the y-axis. And we interpolate them automatically, so if you don't provide any values for the motion component, it's going to use a no wobble effect, so it doesn't wobble a bit at the end. And then we just use these values to draw all the rectangles. So that's why you have the x binding, the y binding, and the height at the end, so we can make them larger, bigger, taller, or smaller. Another example I really like is the lazy Sudoku example from Chris, sorry. Now, this example is a bit different because it originally uses the transition group. So it's a very short example, and you get a nice animation of reordering thing. Now, the concept of lazy Sudoku, sorry, I really like it, is if you don't want to do the Sudoku, you just keep shuffling until it finishes. It reminds me to the BOGO sort. Anyone knows what the BOGO sort is? Yeah? It's an algorithm sorting algorithm, sorry, that consists in just shuffling the array until it's sorted. So obviously, it's a very bad algorithm for sorting. And lazy Sudoku is exactly that. You just keep shuffling until you get the solution right. Now, this one is not the original. This one is the one using view motion. That's why you can select the different spring for them. So for example, the wobbly one will look a bit more wobbly. It's funny. But the good thing is you can interrupt the animation in the middle, right? I can just do it in the middle. And I can just keep press as well, and it will not lag a single bit. It will just keep moving around like a lottery, and then I can just release the button, and they come all in place in this, like a flubber, and it looks really nice. The Steve, for example, is a bit more, it wobbles just a bit. But it has the same effect, right? It's very, very funny to see. And at the end, everything comes back to its place, so it's really cool. Just so you can see, I have the original with a slightly modified animation duration because it was a bit too long. So I used a 300 milliseconds duration instead, which is what is recommended by material design guidelines. So when you click on shuffle, they reorder. It looks nice. But if I click multiple times, you can feel that something is happening, that the speed is changing. And if I keep the button pressed, you will see that they don't even move, because the transition takes a bit of time to speed up, so they never actually move. Now, on the other hand, you compare that to the one with view motion, it's so much more fluid. It feels so much more natural. It's so much better. And of course, it's declarative as well. Now, this time we have to play around with the transform, because we have to kind of do what a transition group is doing for us. But it's still approachable. It's still easy to do, and you have this declarativity to make things move around the way you want. OK, so I have a bonus. I'm a bit skeptical about this bonus, to be honest. So when I was doing the slides, I was thinking, well, I have access to numbers. I can tween them. I can do whatever I want with them. And I was like, I can change things on the screen. But what if I change things that I can hear instead, right? What if I can use sounds? What if I can change any property that change how a sound looks like or sounds like? It's sounding already. I don't know why it's sounding already. Oh, it's because it was on the other slide. So this one is not visible on the screen, but you can actually access with. And now I have it twice. There we go. So at first I thought, wow, that can be so cool. I can actually change the speed or something on the song. And it turned out to be not that great. Like, it's not very useful, to be honest, but it's really funny as an example. And it really showcases how the strings can be very powerful. Now, of course, this is yeah, I need to use a public domain sound. So that's why it sounds that way. But it's not that bad, to be honest. So just let me put a bit louder. And what you have here is just the basic view input with a V model. So I can change the rate, which is the speed. But you can already do that with Vue, right? So let's use tweening to change that. And we can have some nice effects. So let's toggle that back. Thank you, thank you. But there is more. Now comes the good part. So with Springs, remember what I said, that you can make something go on forever? Now this is really cool. So let's just give it a try with, let me show you. Toggle back the volume. I'm lowering down the value so we can see how it oscillates to only 1 first. So in this scenario, it goes back to the original value. But if we go to 0, it will never go to the original value. And what we get is a very nice drunk effect. Now, just hear to the original one. It's already a bit drunk, right? Because the sound is... But look at this one. And what is happening is actually very simple. We go from 1 to 1.05, but because we are oscillating, we go back to the same difference. So we go back to 0.95, and then we keep going back and forth, and that's what happens. And we get this drunk effect. So if you ever need to create a drunk effect, you know that you can use Vue Motion to do that, right? Very pragmatic approach. Okay, to get started, what you can use, check view motion, view tweezing. I'm looking for users to get some feedback. I think we can improve a lot and have something that makes tweening animations a lot easier. Also, check tween.js if you want a basic solution to use tweening. But keep in mind that view motion and view tweezing are experimental. I really look forward to improve the API, make it easier to use. So I'm looking for feedback, and feedback is very welcome. I hope you learned something, and if not, that you laugh a bit. And thank you for hearing me.